Like Earth, Mars has differentiated into a dense metallic core overlaid by less dense materials. Current models of its interior imply a core consisting primarily of iron and nickel with about 16 to 17% sulfur. This iron 2 sulfide core is thought to be twice as rich in lighter elements as Earth's. The core is surrounded by a silicate mantle that formed many of the tectonic and volcanic features on the planet, but it appears to be dormant. Besides silicon and oxygen, the most abundant elements in the Martian crust are iron, magnesium, aluminium, calcium, and potassium. The average thickness of the planet's crust is about 50 kilometers, 31 miles, with a maximum thickness of 125 kilometers, 78 miles. By comparison, Earth's crust averages 40 kilometers, 25 miles, in thickness. Mars is seismically active. In 2019, it was reported that InSight, now offline, had detected and recorded over 450 Marsquakes and related events. In 2021, it was reported that based on 11 low-frequency Marsquakes detected by the InSight lander, the core of Mars was indeed liquid and had a radius of about 1830 plus or minus 40 kilometers and a temperature around 1900 to 2000 K. The Martian core radius is abnormally large, accounting for more than half the radius of Mars and about half the size of the Earth's core. To this, it has been suggested that the core contains some amount of lighter elements like oxygen and hydrogen in addition to the iron-nickel alloy and about 15% of sulfur. The core of Mars is overlaid by the rocky mantle, which does not seem to have a thermally insulating layer analogous to the Earth's lower mantle. The Martian mantle appears to be solid down to the depth of about 500 kilometers, where the low-velocity zone, partially melted asthenosphere, begins. Below the asthenosphere, the velocity of seismic waves starts to grow again. And at the depth of about 1050 kilometers lies the boundary of the transition zone extending down to the core.